For problem number 3, we are going to be determining the intervals of where this function is increasing, decreasing, or constant, and we actually aren't going to have any constant going on for this function up here. It is a negative x squared function, which means it's going to be an upside down parabola. And so our graph is going to look like that. Well, hopefully not that crooked, but and so we are going to just have one place where our graph is increasing, and then at this maximum point here, our graph is going to change to decreasing. And so I need to find this maximum point right here to find out the x-coordinate and determine where my graph is changing from increasing to decreasing. It's the x-coordinate that is going to be used to break up my interval. We use the domain for the numbers that start and finish each interval. So I'm going to put that function into a graphing calculator, and then after I put that into the graphing calculator, I'm going to use my max feature to get that ordered pair. So we'll go ahead into y equals, and I'll click on negative 0.2 parenthesis 5x plus 62 and close it, square it, add 23, and then I'm going to hit graph. And I see over here that I cannot see my graph very well. So I'm going to zoom out and see if I can find where my graph is. I hit zoom, then 3 for zoom out, and I have to hit enter first before my graph will do the zoom. And then hopefully I see it, and I do. And if I want to now zoom back in specifically to the section of the graph where my max is, then I'm going to use zoom box. You can change the window by hand, but I prefer to use zoom box. And I don't know where my cursor is. I got to find it. There it is. So I'm going to put my cursor by moving these arrows to a corner of the square that I'm going to draw around my function for where I want to zoom into. The corner of the window I'm going to create, and I'm going to hit enter to set that corner, and then I'm just going to arrow left and up to draw a window. I just guess I could just hold that down. And that's not like perfectly even, but it doesn't have to be. I'm going to hit enter, and now I will be zooming in nicely to the portion of the graph that contains my maximum point right there. So now I'll find that max by hitting second trace, which gives me the calc feature above. And then I'm going to click on maximum, or 4. My left bound wants me to be on the left side of my max, so I set that by hitting enter. Then my right bound wants to be on the right side of that maximum point, and I'm going to set it with hitting enter. And then my calculator wants me to guess where the max is, so I'm going to go right on top of that hill as close to that max as I can, and I'm going to hit enter. And then it tells me that my x-coordinate is negative 12.4. The y is 23. I don't even care what that y is for this problem. I need that x-coordinate of negative 12.4. So I'm going back and filling in that x-coordinate at that point. So I think it was negative 12.4. And there we have it. That's all I need. I don't care that that y value was at 23 because I'm not even going to use it. My graph is increasing from negative infinity up until negative 12.4. And then my graph is decreasing from negative 12.4 to infinity. Okay, so let's go ahead now and take care of number 4 and number 5. For the piecewise function, I want to find the specified function values. f of negative 5 says plug a negative 5 in for x and calculate out an answer. Well, I need to make sure I put the negative 5 into the correct equation. The first equation wants you to plug in any x value that is less than or equal to negative 3. The second equation wants x's that are greater than negative 3 but less than or equal to 7. And the last equation wants you to plug in any x in this list that's bigger than 7. So first equation is going to take all the values that are less than or equal to negative 3. That's negative 5 and also negative 3. Those two fit the right criteria for that first function, 2x plus 6. Negative 5 is definitely less than negative 3, and negative 3 is less than or equal to negative 3. And then I'll go ahead and use that equation. So I'm going to do 2 times negative 5 plus 6, and negative 5 plus 6, 2 times negative 5 is negative 10 plus 6 is negative 4. And then we're going to put a negative 3 into the same equation, and you get 2 times negative 3, which is negative 6 plus 6 is 0. Now that's done. Those two are done, and we're moving on. The next function, 2x squared minus 5, wants me to put in any x's bigger than 3, but less than or equal to 7. And all three of these numbers are bigger than negative 3, but less than or equal to negative 7. So each one of those is going to go into the second function. I'm going to plug in a negative 1, get an answer. I'm going to plug in a 0, get an answer. And I'm going to plug in a 7 and get an answer. Where am I putting it into? This equation right here, 2x squared minus 5. So I'm going to do f of negative 1, which is 2 times negative 1 squared minus 5. And negative 1 squared is 1. 1 times 2 is 2. 2 minus 5 is negative 3. Done. Now I'm going to put a 0 into the same function. And 2 times 0 squared is 0. Minus 5 is negative 5. And then finally, we're going to do 2 times 7 squared minus 5. And you get 49 times 2 is 98, minus 5 is 93. And then finally, any number in this list of x's that I'm plugging into my functions, any number in that list of x's that is greater than 7 goes into my final equation here, and my function is just straight up 8. I don't have anywhere to plug that 2 million into, so it's a done deal. The answer is just plain old 8. You don't have any x to plug into, so it's already calculated out for you. Okay, so all of these are the answers. This is just the work. You can mental math these problems if you want to. I just wanted you to be able to see what I was doing, so I wrote down the work. You don't, like I said, you don't have to. All right, number 5. We're not evaluating a piecewise function given some inputs. We are going to be graphing. So I have to graph the equation of this line, 2x plus 6. I have to graph the equation of the line, y equal negative 5, and I have to graph the equation of this parabola, upside down parabola, of negative x minus 3 squared plus 4. So I have a line with a slope, a horizontal line, and then an upside down parabola. Now over here to the right tells you what x's that you can use for each little xy table that you would make if that's how you're going to end up graphing it. So I can use any x values from my xy table for this function right here that are less than or equal to negative 3. For my second function, I can use any x's that are in between negative 3 and 2. And for my final parabola, I can plug in any numbers that are greater than or equal to positive 2. Now, I don't care how you graph these. Graph them like you did in Algebra 1. Graph them like you did in Algebra 2. Use your graphing calculator to get a table. Use like whatever method that you know how to do it, go ahead and graph it. But I want to stress that if you look at these numbers here, the negative 3 and the 2, that tells you how you can break up your graph paper to make sure you're graphing everybody in the right spot. My first function gets graphed to the left of -3. So I'm going to put a little divider there. And if you want to get impressive and not put a divider in, you don't have to. You're not really supposed to have it there technically, but guess what? I still put it in there anyway because it makes sure that my functions are all lined up nicely. And then the graph in the middle is going to go from -3 up to +2. So I'm going to put a little divider there. And then my final function is going to get graph to the right of 2. Now, if you have the equal sign underneath, that is going to be a closed circle on the end of your graph. If you do not have that extra equal sign in your inequality, they're going to be open circles at those endpoints of your graph, and then I have another greater than or equal to symbol, so because it has equals, that'll be closed right there. Okay, so let's go ahead and do our graphing. If you know how to graph using slope-intercept, go ahead. Just make sure while you're using your intercept in the middle that you're not actually drawing on the graph paper there. You only want to draw on the graph paper to the left of -3 for any x that is less than or equal to -3. And I'll do a little mini XY table down here. So I can use -3, including it, nice closed circle, and then, I don't know, maybe I'll do -5. So when I plug in a -3, I get 2 times -3 plus 6, and then 2 times -3 is -6, plus 6 is 0. There's one ordered pair right there, and to graph a slopey line, a linear equation, I need 2 points, so let's go ahead and do another. 2 times -5, which is -10 plus 6, that gives you -4. Okay, so we are back 3, up 0, and then we are back 5, down 1, 2, 3, 4.
Can you buy me another little pink nookie again? Because I actually want another nookie. Because if I start to cry, I can quickly try to remember about it, and then quickly try to get it, and then before I cry, you can put it in my mouth.
Okay.
You're going to have to give me one someday. Just try to remember I said that already.
Okay. Okay, so the middle function here is very, very easy to graph. It is a horizontal line where y equals -5. So I'm going to count down 1, 2, 3, 4, 5. Put a tiny, tiny little dot there just to mark that spot. You technically don't need that dot. And then straight across, all across the interval from -3 to 2. I got a horizontal line, and then I'm just going to put open circles there at those endpoints because technically -3 and 2 are not included in the interval. So open circle. And then finally you have your parabola, your upside down parabola, and I'll do a little XY table for that. And I'm going to use the point 2, and it's a closed circle there, and then maybe 3, and then maybe 4. And that probably is enough. So let's go ahead and substitute into the formula or the function. You have 2 minus 3 squared, which is -1 squared, which is +1. The negative outside will end up giving you -1, and -1 plus 4. -1 plus 4 is 3. And then we're going to put in a 3. And then I do 3 minus 3, which is 0. 0 squared is 0. Plus 4 is 4. And then finally we'll put in a 4. And then we have 4 take away 3 is 1. 1 squared is 1. The negative carries over. You get -1 plus 4, which is 3. All right, so I got a couple ordered pairs. I know that it makes an upside down parabola because I recognize um, that type of function. And so that helps me to know what I should be sketching and how many ordered pairs I should be finding. If you graph a line, you only need 2. If you graph a horizontal line, you don't need any points. If you know ordered pairs or an XY table, and if you graph a parabola, you're going to need a couple points there to get that smooth curve. So I'm going to go over 2 up 3, and it's a closed circle. And then I'm going to go over 3 up 4, and then I'm going to go over 4 up 3, and I probably could get like one more point there actually to make my graph a little more precise. Let's see what happens when I put in a 5. I'll just do it up here. 5 take away 3 is 2. 2 squared is 4. Negative 4 plus 4 is 0. That calculates out to 0. So over 5 up 0. And then I'll draw in my smooth curve. Now if you have no idea that that function makes a parabola, go into y equals in your graphing calculator and put it in and look at the graph. You can even find the table right in your graphing calculator. You don't have to do this by hand like I did. Just put it into your graphing calculator and make some mini XY tables. Just make sure you use the right ordered pairs the right X values that are in each domain. Don't pick X values to plug in your table that are not in each interval that you see next to your function.